and then I'm going to come back and look at what the video does. Okay, so there's the video. I wiggled it around. Okay, I'm going to go back to my Notability and just press recording, and we're going to continue. So here's my suggestion for solving this algebraically and getting those solutions. I would say that let's let theta take the place of the 2x minus pi over 4, because I don't recognize that on the unit circle. I'm not sure where to graph that. Okay? And I'm going to solve a basic trig function that allows me to use what I know. So I'm bridging right now. We're making the bridge, building the bridge. Okay, so let's do this instead. The cosine of theta equals 0. This is something I can pretty easily handle if I were to draw a unit circle. Cosine is your x-axis, right? So, or it's the values that are along your x-axis. Where'd my circle go? So, would you consider pi over 2 to have a cosine of 0? And also at 3 pi over 2, you have a cosine of 0. And so, let's just talk about what we learned already. We could say then that theta is equal to pi over 2, and would it be okay for me to say plus pi n if I was finding all of the solutions? Right? Because that's a distance of pi to get from here to there, and then you continue to spin pi left or pi right. That would give you all of your solutions. So there's our starting point. That's what we know how to do. So now what I'm going to ask you to do, now that we've solved for theta, is we're going to put the horizontal compression and the phase shift back into the equation, and we're going to do some algebra. So I'm going to go back and replace theta with 2x minus pi over 4 equal to pi over 2 plus pi times n. And I am going to restrict n. N isn't going to be every number, because that's not what I'm looking for. I'm just looking for how many solutions are in one revolution. So how do you want to solve that?
Clear the fractions.
Do you want to clear the fraction? I like that idea. Do you guys want to do that? Yes. Okay, so let's clear the fraction. So let's say the largest denominator is 4. And I could make this denominator a 4 easily. So I'm not going to do that. I'm just going to multiply, I don't want an eraser, give it back, everything times 4. And I like to do that separately so that I can cross simplify whenever I want. So new form of this equation would be 8x minus pi, because cancel the 4's, and then 2 goes into 4 twice, so that would be 2 pi plus 4 pi n. That looks good. That makes this a little easier to manipulate. We're not spending our entire problem solving in fraction form. They are. And now we'll solve for x, because that's what we're looking for. So we'll add pi. Then we're going to add pi to 2 pi, because they are like terms. We are not going to add pi to 4 pi n, because they are not like terms. So we get 8x equals 3 pi plus 4 pi n, and then divide by 8, and we get x is equal to 3 pi over 8 plus 4 pi over 8. That's okay. It's okay to leave it in that form, because we're not looking for all of the answers. But to be honest, I could simplify that to pi over 2 times n. I could. It doesn't make it helpful, which is why your calculator is really going to be a handy little tool. Now here's the thing. I don't want n to be any integer, so I am going to restrict n to be the numbers 1, 2, 3, and 4. And I'm going to see, with all of those answers, if I'm going to get answers that are within my interval 0 to 2 pi. So first, my first answer is 3 pi over 8. So I'm going to write that answer down. That's my first solution. Okay. And then I'm going to go see which other values are in the solution. So if n equals 1, that would be, 3 pi over 8 plus pi over 2 times 1. And remember, you could just if you want to use your calculator, you could use your calculator for that. Or you could use 4 pi over 8, right? Because that's just another form of pi over 2. And 3 pi over 8 plus 4 pi over 8 is 7 pi over 8. Well, that's not even pi, because pi would be 8 pi over 8, right? So I think I'd like to keep that answer. Okay, so that's part of my solution. Now, what if n is 2? So that would be 3 pi over 8. I like what you're thinking. Plus pi over 2 times 2. Or 8 pi over 8, right? And that would be 11 pi over 8. Now we could continue to just go, all right, that's less than 2 pi, right? Because 16 pi over 8 would be 2 pi. So I would want that answer. All right. So I like the suggestion that's going around. Let's just keep adding 4 pi over 8, right? Instead of pi over 2. So that would be if n was 3. So that would be our third rotation of pi over 2. And that should be an 8, not a 2. And that's 15 pi over 8. So this is if n is 3. Right? So that's less than 2 pi. Well, let's just check if n equals 4. So we'll do one more adding. So that would be plus 4 pi over 8 times 4,
16 pi over 8.
which is 2 pi, right? So that would be plus 2 pi. So actually that would be, oh no, because we're just doing 4 pi over 8. That would be 19 pi over 8, right? And 19 pi over 8, so I'm going to list that. 19 pi over 8, that's too high. So it's not that. So I can stop checking answers. But I really like the suggestion of just starting with 3 pi over 8 and adding 4 pi over 8, getting an answer, adding 4 pi over 8, getting an answer, and then you don't need your calculator. It's a good suggestion. But there you have, that's supposed to be an 8, there you have your solution. So a little more complex than the problems we've been working on. But I tried to bridge it from something that we're very familiar with to the horizontal compressions and the phase shifts. Okay? Questions? All right. Then we're going to move on to the two problems that are quite a bit simpler. Here we have the problem 2 sine squared u equals 1 minus sine u. Okay. Well, that feels quadratic to me. And it feels like a trinomial. 3 terms. One of them squared, one of them's to the first power, and then one of them's a constant. So my suggestion would be to do this. Rearrange the problem by adding sine u and subtracting 1 to the other side. So we get 2 sine squared u plus sine u minus 1 equals 0. So when you're doing quadratics, typically if you have the a term, the b term, and the c term, you make the equation equal 0, and you try factoring, or you try your quadratic formula, those sorts of things. Now you might feel comfortable factoring it in its form right now. You might prefer to say, I'm going to let x replace sine of u, just so it feels more like an algebra situation. So we could do 2x squared plus x minus 1. That might feel a lot better for most of you. You don't have to put it in that form if you can factor it in its original form, or you can use your quadratic formula. I don't care. I would factor this personally. So let's factor. So we multiply 2 times negative 1, that's negative 2. And your b term is 1. So we're looking for the two numbers that satisfy those conditions. Well, when you're multiplying to get 2, you can only have 2 times 1, but it's a negative 2. So which one of these numbers should be negative 2 if when I'm adding them I get a positive 1? All right, so positive 2 and negative 1 are the numbers that will satisfy this equation. So I could break this 1x into 2x minus 1x, and then bring down your 2x squared and your minus 1. And that's if you're still factoring using this grouping method. Then cut it in half, factor the front, factor the back. So we'll factor out a 2x, leaving you with x plus 1. And in the back, we'll factor out a 1, leaving you with x plus 1. So you can see the common factor now, which is x plus 1. And the leftover factors, 2x minus 1 equals 0. So now we'll find our zeros. So x plus 1 equals 0. 2x minus 1 equals 0. So x equals negative 1. And x equals 1/2. Check my math, add 1, divide by 2. So I solved the quadratic, but it wasn't my job to solve for x. It's my job to find the value or the angle u. So now that I've used my quadratic strategies, I'm going to go back into the equation and replace all the x's with sine u's. So the sine of u equals negative 1, and the sine of u equals 1/2. And we're still working on the interval 0 to 2 pi, so let's talk about where that happens. Sine, again, you recall, is your y coordinate. So sine equals negative 1 down here, and 1/2 up here. So if I get my unit circle here, pretend it's hitting the negative 1. Can you do that?
Sure.
You can't? Okay, I will resize it, you little brats. There, that's better. I'll just extend that out. Okay, so we're looking for the value of u here. So what angle is this? If sine is 1/2, it's a 30-degree angle. So in radians, that is pi over 6. And over here, where your sine is 1/2 again, 5 pi over 6. So I can say with guaranteed that u is equal to pi over 6 and 5 pi over 6. They don't need to say plus 2n because that will push me out of the interval that we're looking for. And now the only other equation that we have to solve here is this one, where sine of u equals negative 1. And that happens down here at 3 pi over 2. And so that is your solution set. That one I don't think is quite as bad as the first one, or quite as, I don't know about bad, but quite as challenging. Questions about that? Okay, then we are going to move on to the last question, which is this one here. Now, a couple people today have suggested that we divide both sides by sine x to solve this equation. And when you do that, you eliminate the sine expression from the equation completely. And that means that you're going to eliminate some of the solutions, right? Okay, so don't do this, just watch. How many of you are thinking, okay, I can just divide both sides by sine of x? So I have tangent squared x equals 1. I like that, that's fun. But I just eliminated all of the answers are sine of x. And I can't do that if I'm trying to get the full set of solutions. So here's my suggestion instead. Let's bring